Alright, so this video will focus on 2.3 from the Advanced 2 book. And the very first thing has these ordered pairs, and it says for the first one, just go 6 units to the right. So I have my little equation here, or my rule, x plus 6 and y. And this one, my rule is 1 unit to the left and 3 units down. So it's x minus 1 and y minus 3. So let's apply these numbers to this rule. So for C, for instance, if I say x plus 6, I go over 1, 2, 3, 4, 5, 6. My y stays exactly the same, so it's right here. A is 1, 2, 3, 4, 5, 6. Y stays the same right here. For this rule, I'm going to go to the left one, so minus 1, x minus 1, and then I go down 3. 1, 2, 3. Over 1, down 1, 2, 3. Over 1, down 1, 2, and 3. So it says tell whether the blue figure is a reflection of the red. Well, if I look here, if I reflect or put a mirror up here, this would absolutely be a reflection. You could tell because this is exactly the same distance from the mirror as this is. This is exactly the same distance as this is from the mirror. So this is a reflection. This one is not a reflection. I know that because if I think about a mirror, everything's kind of flipped around oppositely. So this is going to be this far away. So it would have to be this point should be over here somewhere. It should be exactly the same distance away. So reflection, no reflection. How can you use reflections to classify this pattern that we're going to show you before? So if I look here, look at this pattern, and it says, is this pattern a reflection of itself when folded horizontally? And then it says, if you fold this on itself, will it be a reflection as well? The case is, for both of these, it will be. And let me show you why. So if I look here, the pattern looks exactly the same. So if I fold it over, this would fold directly over the top. So it is congruent. It goes right over the top of it. Same with this one over here. The pattern coincides as well. If I look at this one, it says, is this pattern a reflection of itself when folded horizontally or vertically? If I fold this on itself, unfortunately, this will not be exactly the same. This piece here will be down here. So it does not fold this way. However, if I fold it vertically, meaning on top of itself, so it goes on top, if I look at it, this piece would be over here, so neither one is going to be a reflection. It is neither. This one here is absolutely going to be a horizontal. It'll flip over the top. And then for vertically, it will not work vertically because this piece does not fold over here perfectly. So again, we have the neither for the first one and then horizontally for the second one. And then we're going to go, and we're still talking about new shapes that if I'm in quadrant 1 and I move it over, are they parallel? Then it says here, the vertices of quadrilateral are right here, and draw the figure in reflection of the y-axis. So if I do this, here is the figure. Now if it's reflected across, you're going to notice here that instead of being a negative 2, it will be a positive 2. Instead of being a negative 1, it should be a positive 1. Instead of being a negative 4, it'll be a positive 4. So this is how it works. Again, it's the exact same distance across. So this is a mirror right here. This distance right here is the exact same from right here. And so a good rule that you might learn is that if it goes across the y-axis, if this is an x, this will become the y value of it. I'm sorry, I said that backwards. If the x is a positive, the x will be a negative on the other side, and so forth. In this case, it was a negative and it became a positive. So the term that changed was the x value. Even though we're going on the y-axis, because I'm shifting everything over on the x-axis. See, it's going over 1 unit, goes over 1 unit. For this one here, it says the vertices of the triangle, here's what they are, and it says in its reflection on the x-axis this time. So now it's going this way. So think about how things are going to shift over. If this is going to be the mirror, this A is going to show up down here. So we're actually moving the y value, aren't we? So it was a positive at first, like this ordered pair is negative 1 and positive 1. Now it will be negative 1 and negative 1. So the y value is changing. So very similar to what we had before. It's just that if it's going to be the x-axis that is the mirror, then the y thing will be, the y value will become a negative or a positive in this situation, because this is, the mirror is on 0. And now it says, is this a reflection of the non-shaded? Well, no. Yes. No. Yes. Is this a reflection? It's not, because if it was a reflection, it would be directly across. This would be the same distance across, and I'd have to rotate this over, and it's not correct. This one here is not a reflection, again, because this would have to be turned the other way around or rotated. This one here is a reflection. This point aligns to this. So no, it's a translation. No, it's a translation. I just shifted it over. Yes, it does get reflected across the axis. Here is the big idea, or the key idea from here, so make sure you read this. So draw the figures. Here they are. And it says reflections on the x-axis. Again, remember all that your y. So in this case, it was -1, 1. This will be -1, -1. So all my y values are the opposite. If this was -1 and 1, 2, 3, it's now going to be -1 and 1, 1, 2, and 3. So -3. And if it's on the y-axis, it's going to be, if you look at it, so all my x values now, if this was a -1, it'll be a +1. This is a -4, it'll be a +4, and so on. And they will be congruent, because all we're doing is we're shifting them over. If it's a complete reflection, it's got to be exactly the same. All right, and that